Hey everyone, today I'm going to go through our new feature, Flash, which lets you run AI workloads on runpod serverless using a single decorator. So no Docker or intermediary container software, just Python. By the end of this video, you'll go from zero to running GPU accelerated code on runpod serverless, and I'll show you how to build a full production API in just under 50 lines of code. So Flash is an application framework for distribution and orchestration. One of the biggest roadblocks we've heard from users regarding serverless is it's just not as user-friendly as developing in a pod, and all the extra layers involved make it a bigger technical lift. One of the primary goals behind Flash is it just lets you focus on code without having to build and manage Docker images or containers. Flash will provision everything you need to do behind the scenes and do all the orchestration. Although things still do run on Docker behind the scenes for purposes of actually executing your code, you personally do not need to touch it. The only real prerequisites are a runpod account, having a balance, and an API key. And you'll also want to ensure that you have the latest versions of the runpod and runpod-flash packages. So here's a quick flow chart of how it works. You use the @remote decorator to actually run your code, and then the infra silently creates and manages your serverless endpoint with the parameters that you set. This is something you'll still see for yourself if you go into your serverless endpoints in the UI. The code runs on the hardware you specify, and then returns the results to you. Although you certainly do have the option to build and maintain your own Docker images, it is now optional rather than a requirement. Okay, so I've set up a local environment with VS Code on the left and the runpod UI on the right, just so I can demonstrate these things. I've already run pip install runpod and runpod-flash on my local machine, so the next step is going to be exporting the API key, just like this. So looking at this code block here, this @endpoint decorator is how you invoke a Flash function. And then here's the name of the serverless endpoint that we'll be creating. Then we have our GPU specs that we'll like to use. And then any dependencies we'll need will be defined here. And then this is a code block that we actually be running on the serverless worker. So if we just run our script here, just like any serverless endpoint, it's going to take a moment to start up because we're basically doing a cold start. But if we refresh, we can see that we will go from nothing to having our endpoint created, and we can actually go into workers and see the worker spinning up. So this code is just a simple function that pulls the name of the GPU spec and outputs it to the terminal. And you can see that we define an RTX 4090 and we got a 4TX 90. And now that our endpoint is warm, we run our script again, it should run much more quickly. And if you want to add an entire group of GPU specs, you can do that by adding GPU group and then changing this parameter to a list, and then GPU group Ada 24, GPU group Ampere 48. And we'll save and then run. And it'll take the sec to run, but if we refresh our runpod UI, and if we go to edit the endpoint, you can see that even though the jobs are still waiting, it immediately upgrades the GPU specs in the endpoint. And likewise, you can also modify the number of workers just by adding a workers variable and then sending in a list of the number of active workers and then the total number of workers. And save, run, and refresh. And the number of workers has been updated here. So I've got a fresh project here. Before I do anything else, let me just kind of walk you through it. Now, if you go to main.py, all this is just a standard fast API app. Just a couple of lines. All it does is just mount a router. And then if we go to endpoint.py, this is where we got our Flash decorator, where we define our list of GPU specs, our number of workers, and our dependencies needed. And in terms of what it does, all it does is just create a request and do a simple matrix multiply, and then return the result. So in our first terminal, I will do flash run to set up the server. And in our second, I will send the curl request. We tab back to our first, we should see the request. And if we refresh our serverless page, we should see the new endpoint with the worker spinning up. And we'll just give it a sec to run. And now that it's finished running, we can look at the result and we have our numbers here in the JSON. Thanks for watching this demo of our new feature. We're super excited to make serverless a more accessible environment to develop for. We understand that Docker is powerful, but it might not fit everyone's use case and turn into a chore instead. The idea for this is to just magically work with an absolute minimum of effort while also reducing development costs, because now you can simply send requests when you're ready to test rather than simply having to keep a pod running the whole time. If you have any questions about how this works, feel free to ask us, and we'll see you in the next one.